Okay, now let's try to understand the second algorithm in the list, which is called as naive bias. Okay, now before I talk about naive bias, can someone help me with understanding the word called naive? Friends, what do you mean by naive? What is the English meaning of word called naive?
Innocent, new.
Innocent, right? Sometimes stupid, right? But what is this color? So it means the moment you try to pay attention to those two words present in this algorithm name, you will get a lot of understanding about what are we going to talk about, right? So if someone is having little exposure to statistical world, right, Bayes theorem plays a very crucial role, right? So most of the algorithms, right, are based upon the Bayesian statistics. Okay, so similarly, this particular algorithm by the name called naive Bayes is again based upon your Bayes theorem, but what it is trying to do, it is going to make an innocent assumption. What was the innocent assumption? So as an example, you're trying to let's try to take a same case of um, breast cancer detection, right? Before you try to certify, before you classify a particular patient into a having a cancer or not, you're trying to depend upon how many predictors, friends? How many factors did we consider before we classify or say a particular patient belongs to a malignancy or benign? Remember what was the count of the input variable that we have considered?
165.
165. What was that number? Interesting. The
No,
total
what
number
did you
of
say?
rows present in the use case are 569. I have reserved 469 for my training, 100 records
Oh,
for my
okay.
testing. There are 30 input
Yesterday's
variables.
example, I was thinking, sorry.
Oh, okay. Right. So this is it means we have considered 30 input variables and their associated values before I try to classify a particular patient details into a malignancy or benign. Right. So similar, but when it comes to Bayes theorem, it is a classification model. What do you mean by classification model? It means even naive Bayes is going to help me in all those kind of a problem statements where my output variable has discrete values, right? So even naive Bayes is a classification model, and but it is heavily dependent on your Bayes theorem. If it is dependent upon the Bayes theorem, why should I have another name called as a naive Bayes? Because it is going to make a simple, silly, and innocent assumption saying that there is independence among your predicted variables. Can someone explain what does it mean? Independence among predictors. You have seen this word, right? N number of times. If I say that the input variables are independent of each other, what does it mean?
It's not dependent on the first output.
Okay, so when we say independence, friends, in the high correlation we have seen this, right? In case of probability of events, we have seen the word called independence, right? We have seen at least 3 to 4 instances where we use this word very commonly.
Mutually
Can someone
exclusive.
explain? Go ahead, Tejashree.
Mutually exclusive.
This is the second time that I assume that you have answered the very similar way, mutually
Okay.
exclusive. Okay, that should be okay. But again, let's say the moment we say mutually exclusive, we are trying to always talk in terms of just a probability and events, right? But my question was, there is an independence among input variables. What does it mean?
They are not related to each other.
Simple, right? Friends, let's keep it simple. When I say two variables are independent, what does it mean? Right? The changes in one particular variable is not related, or it is not going to impact, it is not going to change anything on the other variable. Right? That is very random in nature. So there's in the moment you see a correlation plot between two variables, right, which are unrelated, unassociated. What do they say? They are scattered all around the dimensions. Right? So it means the presence of a particular feature, right, is unrelated to the presence of any other feature. To keep it very simple, this is called independence, right? The changes in one variable, if you try to associate with any of the other variable, there is no association at all. It is haphazard. Got that point? Are we clear? What do you mean by independence?
Yes.
Yes.
Very good. So this is what the naive Bayes means. It means naive Bayes is a classification model which is based on Bayes theorem, but the only difference between naive Bayes and the actual Bayes theorem is it is going to make a simple and silly and naive assumption, which is independence among predictor variables. This is the fundamental difference between a Bayes theorem approach and a naive Bayes approach. Okay, are you clear about this? What is the fundamental difference Bayes theorem and naive Bayes? Can someone repeat that? What is the
Naive
difference?
Bayes it assumes that the predicted variables are independent.
Very good, simple, right? There is an independence among the predicted variables. So in other simple terms, what does it mean? So if you wanted to rewrite this in a little different way, a naive Bayes classifier, right, assumes the presence of a particular feature. Whereas friends always understand independent variables, predictor variables, input variables, X variables, these are one and the same. Hope everyone is clear about this. Agree? And the output variable, Y variable, dependent variable, target variable, response variable is one and the same. Okay, we use different names, right? Just like an alias or aka names, right? So it means the presence of a particular feature in a class is alternate and related to the presence of any other feature. Okay, so this is what the assumption is being, but why it is required? Let's try to first understand what is Bayes theorem. Okay, then you will get to know what is the problem with Bayes theorem and how Bayes is trying to remove some of the complexities of your Bayes theorem and still going to give us very good results. So the Bayes theorem goes this way, friends, right? Pay attention to this. So this is the formula for your Bayes theorem, right? What is formula for Bayes theorem? And sometimes, right, very hard chances, but at least have come across two situations where people ask like, can you please write the Bayes theorem and explain it? Okay, very weird, but sometimes what happens is because this is one of the theorems that everyone tries to understand in great detail, because the moment you try to deal with some text data or NLP data, human text English data, right? So Bayes theorem is the one which is going to help us a lot. So the reason maybe they have like little more association with this particular algo. So please do pay attention to the formula. The formula of Bayes theorem goes this way: P of C given X. Friends, what does X mean here? I just talked about. What does X mean here?
Precondition.
So independent,
Very good. Those
event.
are independent variables. When I say independent variables, what does it mean? It are nothing but input variables. Agree? X stands for input, Y stands for your output. Right? Very simple. Friends, the moment you try to work on the statistical modes of machine learning, these are very common synonymical terms that you need to remember. Okay? Input variables means the X variables means the independent variables, right? The independent variables also mean as predictor variables. Okay, these are the different names that we always use very commonly, right? So the moment I say here, I'm trying to calculate probability of, given all the evidences of your input variables, what does it chances that it belongs to a particular class called C. So where does you find the C values? Friends, where do you find the C value? As I said, it is a class. What do you mean by class? Am I audible?
Yes.
What do you mean by class in general?
A
No?
Group.
set,
Okay.
Definition.
a set, data set, or a group.
Go ahead. One at a time, please.
A data set or a group.
Okay. Completely out of context. Okay. Friends, we are going to talk about the moment we talk about machine learning, what it is trying to do. The supervised way of machine learning is always identifying the relation between input and output. Is everyone clear about that? Agree? Because we are working on a labeled information, the ultimate goal of any algorithm, it could be KNN, it could be Neovas today. On Monday session, I might be talking about decision tree. The ultimate goal of every algorithm is to understand the association or relation between your input variables and output variable. Agree? So since I'm going to talk about probability of C given X, right? The X stands for input. What does class stand for then?
Output actually. So output class
Output.
question.
Obviously, because your output variable is not numerical in nature, right? Your output variable will have some discrete values, which are nothing but classes. Isn't it, friends? A simple, a logical thinking will give you the answer, isn't it? What are we trying to find here? We're going to find the probability that given all the input variable values, what are the probability that it will belong to a particular class? When it's a class, the output variable will have some values, right? That's what you're going to find out. Whether a particular person will have a cancer, right, is one class. Not having a cancer is the second class. Agree? If you're trying to do a fraud detection, what is the probability that given all the X input variables values, whether it will belong to a fraud transaction is one class, not fraud is another class. Agree? Able to understand this, friends? So sometimes you need to think a little logical given the given scenario so that it will be easy for you to understand some of the other literature. Because as I said, you cannot learn everything as part of the data ecosystem in a stipulated amount of time, right? Even after the program completion, you need to keep this upskilling, right? Learning curve a lot. So the reason sometimes it makes sense for us to think a little generally, a little analytically, a little logically, so that you'll be able to understand the literature too. Is everyone clear about now? What does X mean and what does C mean? C are nothing but the discrete or categorical values or classes present in your output variable. Are you clear on this? Which is nothing but called as posterior probability, right? So at least for the reways, please do remember the formula and remember the names of those particular each one of those term present in the formula. Okay, are you clear? Tanvir, if you're not talking, please go on mute. Thank you. Okay, so this is what your base theorem is going to help you. Given all the input values, it is going to help you with the probability value associated whether it belongs to 2 class or 3 class or 10 classes. I'm not bothered. So I'm just trying to maintain it as just a C. Okay. And how does the formula goes like P of C given X is equal to P of X given C multiplied by P of C divided by P of X. And each one of the term has a name to it, right? The one that you're going to find out is the probability of a particular record given its input values, whether it belongs to one of the classes present in your output variable, which is nothing but called as posterior probability. Okay. And when we talk about the first term, which is called P given X, right? This is called as likelihood. And the second one, which is called as P of C, which is called as class prior probability. And the moment you're going to see P of X, which is called as predicted prior probability. I know people wants to know how does this help, right? We are going to take an example. Are you clear about this, friends? Any questions? Are we clear about how does a Bayes theorem formula looks like and what does each one of the terms mean here?
Yeah.
Very good.
Yes.
Right? I'm just trying to mention the same. So P of C given X, which is the one which I'm going to calculate, is called as posterior probability, and P of C is generally called as prior probability of the class. And your P of X given C is generally called as a likelihood value that you're going to calculate. And finally, P of X is nothing but it's a prior probability of the input variables. Since it is input variable, we generally call it as predictor. Okay. For this, right, let's try to take a simple example. Okay. Example of Bayes theorem. Okay. Again, try to take a simple example so that you will be able to understand, try to substitute the values manually. Right, I'm again considering a simple pack of playing cards. So how many cards do I have in the set in total? Don't say jokers, okay?
50,
It would be a
52.
standard 52. Okay, and how many of them are face cards? Do you know what are called as face cards?
Yes.
12.
Will you please list down?
JQK.
There you go. We have a player here. Santosh, onlinerummy.com?
No.
Just kidding. No, just kidding. Okay. So JQK, right? It's 12. And what does it mean? J is of 4, Q is of 4, and K is of 4. Right? I'm just trying to provide you some information because not everyone is a great player here. So I'm just trying to provide. There are 52 cards, and the moment we say face cards, those are nothing but JQK, and each one of them will have 4. Okay. Now the question here is, I want you to identify this particular value. Is it looking very similar to the formula? What I'm going to identify, given a face card, what is the probability that it will belong to a type called king? So if I use this formula, can someone help me to expand the formula? How the formula would look like?
P of
Look at the formula.
K,
P of
P of face given
face.
king
Mm-hmm.
into P of king
Very good.
divided by P of face.
P
Probability
of
of
face.
yeah.
Right. So this is how it's going to help you. But this is a very simple example. We are going to take a real-time implementation and a lot of things. But for now, since we just exposed to a formula, we are just trying to solve a simple problem statement, and the probability values goes like, given a particular face value, what is the probability that it will belong to a class called king? Okay. Now P of face given king. What is the probability of these, friends? It is a conditional probability. So the reason I touch base upon this particular conditional probability a little more as part of your inferential statistics, if you remember. How do you calculate the conditional probability? P of face given king. What does it mean? Given it is a king card, what is the chance that it will belong to a face? Simple one, because every king card is a face card, to keep it very simple, right? You don't even require a formula because it's very simple set that you're working on. Now what is the probability of king, guys? What is the probability of king?
4. Oh, 4 by
4.
12.
Seriously?
4 by 52. Yeah, correct. So we're
So should
talking
I
about all
provide an
cards.
additional sheet? No. Should I
No,
provide an
no,
additional
no.
sheet? Not required,
No,
right?
no,
Very good.
no, no.
Now what is the probability of face?
12 by 52.
12 by 50.
12 by 52. So do I have all the required information to substitute? Do I have?
Yes.
Very good. Now let's try to substitute the values then. Okay. So I'm going to say P of face given king. What is the value of it? 1, right? Multiplied by, what is the second term? Guys, what is P of king?
4 by 52.
4 by 52. Right? Right? Agree? Now, what is the denominator?
12 by 52.
12 by 52. Right? The moment I try to solve it, what would be the value? It would be 1 by 3. Right? And if I want to talk in terms of floating point number, then this would be 0.333. Is everything clear about this? So this is how your base term is going to help you whenever you have a given input values, and how are you going to calculate the respective probability so that you can assign it to a particular class of your output variable. Okay, clear about this? Any questions? Okay, so the reason we say your base theorem classifiers are best applied. What are the what you call scenarios or cases where you can apply the base theorem, right? Observe this. Your whenever you're working on a particular problem set in which the information from various attributes, again, what do you mean by attribute here? In the context of a data set, what does attribute mean?
Class.
That is nothing but your input variable again.
Input
Friends,
variable.
do not get confused. Input, X, attribute, predicted variables, independent variables, those are one and the same. Okay, don't ever get confused again with those, right? We will be always using the different names because your literature that is available on this particular internet world, right? They use different literatures, right? So let's try to learn as much as possible. Okay, so these particular base theorem classifiers are best applied to to all the problems in which the information from various attributes should be considered simultaneously. So the moment you wanted to consider all the input variable values simultaneously to estimate the probability value. So these are the problem statements that Bayes theorems are best applied to. The moment you think about Bayes theorem, these are the real-time applications that you always see. It does not mean that it cannot work on the batch process, but the moment we talk about Bayes theorem, the beauty of the Bayes theorem, did someone understand how it is different from KNN on a very high level? Don't get into the Euclidean distance formula. I know you are a little statistical now, but on a very high level, what is the one best advantage that you see about Bayes theorem when it compared to the KNN output? Quick. Anyone? Quick, friends. On a very high level.
There is a probability attached to this.
I'm not sure, Manoj, but I'm really getting impressed, right? Friends, this is a probability value. So in case of a cancer detection data set, did you get any associated confidence score or probability values, friends? It always talks in two terms. Either a patient has a disease or patient does not have a disease, isn't it? Agree or not? But here I'm going to talk about the outcome plus a probability associated with respect to the outcome. Would it be an advantage or a disadvantage? Right? It is going to help you. Is it going to help the business in understanding a little more? Because even though business does not belongs to statistical world or not, but the moment people talk about probability, right, it is very easy for someone to interpret or easy to understand. Agree? Agree or not? Acknowledgements, please.
Yes.
Right?
Yes.
So this is the beauty of your naive. Apart from trying to tell you the output class, it is also going to give you the respective predicted probability value too. Right? So the reason it is one of those good machine learning or statistical algorithm which is going to help you in estimating the output variable outcome plus along with its probability. So this is where your Bayes theorem classifiers are best applied to. And the second important thing as part of your Bayesian theorem classifiers are, while some of those algorithms will ignore the features that will have weaker effects. As an example, say, okay, so there is a machine learning algorithm called as an X. Okay, so there are 2000 input variables. Believe me, there are 2000 input variables. Now, few of the algorithms, what do? 2000 number of input variables is like a huge dimension, isn't it, friends? Agree or not? Having 2000 input columns to be considered in order to make the predictions is like a humongous task, right? The model will become too complex. Agree? So what will happen? So few of those algorithms, what do? They try to ignore the variables with weaker effects, the variables which are of less importance. Okay, say as an example, instead of taking 2000, let's say as an example, I have 100 variables. Okay, can we say that each and every variable is of same importance? Can we?
No.
Definitely not, right? So what happens? Few of those algorithms, what do? Since each and every variable is not of same importance, they tend to ignore the variables which are having the less importance, which are having weaker effect on your predictor variable. Yes, they are required, but maybe out of this 100 input variables, maybe there are 50 variables where their contribution is, or where their importance is of just 0.5%. Say there is an x1 variable, the contribution of its in order to predict the outcome value is 0.5. So similarly, there are 50 such variables present in my data set, right? So each variable is contributing 0.5 individually. It's going to make a great sense, friends. Individually, if I try to ignore one, I have 100 variables. If I use them, I'm going to get a 100% result. But few of the variables, that contribution is very minimal. How minimal? Say x1 variable is of 0.5 importance, x2 variable is of 0.5 importance, and x3 variable is 0.5 importance. If you try to look at them, these are not much greater impact on the outcome variable individually. Agree?
Yes.
Right?
Yes.
So if you try to consider them individually, the moment you start removing it, so what happens together? If I try to remove 50 variables, what is the total percentage that I'm going to miss? Can someone quickly tell me?
25%.
25% of the information. So individually they are 0.5% importance, but together, right? What's happening? They are making, or there is a chance that the prediction value would completely change. Agree or not? Right? What do we call it? It means
Yes.
if there are large number of input variables which have relatively minor effects, but taken together, right, their combined impact could be quite larger. Agree? So individual, we have seen this. This is just 0.5%. What few of the circles will try to say, hey, this is just a 0.5% important variable. Let me remove it. Now you keep on removing. What happens? End of the story. 50 variables got removed, and you lost 25% of the predictor power. Right? Make sense? Individually they are weak, but taken together, their combined impact could alter the outcome altogether. Agree?
Yes.
So the reason your Bayesian theorem classifiers are best applied to whenever you wanted to utilize all available data, all available evidence, right, in order to make the predictions better. So these are the two cases. What are the two cases? Whenever you wanted to work on a kind of a problem statements where you wanted to simultaneously predict the probability of an outcome. This is where the Bayesian theorem classifiers work at its best. And the second important thing, while many algorithms ignore the features that have weaker effects, Bayesian theorem classifiers utilize all the available data, all the available evidence in order to make the predictions. Okay? It means it is not going to say that, hey, this is a weak fellow, so let me not consider it for my predictions. No. It is going to consider each and every bit of information, how minimal or how small their effect might be as part of your final prediction values. Are clear? Any questions here, friends? What are the two cases or two scenarios where Bayesian theorem works at its best or are generally being considered? Let me pause for a minute. Any questions here? Just trying to document the same. And the second thing is, what is the second case? Can someone briefly explain that? The first case is where we wanted to consider all simultaneously in order to estimate the probability. What is the second case? Friends?
This where individual contributions are minimal, but collectively they have a very bigger impact.
Very good, right? While many algorithms ignore features that have weaker effects, Bayesian theorem classifiers utilize all the available data. They use all the input variables data so that you can make the predictions very good. So in another terms, right, as an example, if a large number of features have relatively minor effects, right? But what happens when they are taken together, right? Their combined effect or their combined impact could be quite large. Are you clear about this now? Any questions? I'm seeing a little dull faces today. Any reason, friends? Complexity or morning blues? Again, no reply. Friends, what's happening here? Am I audible?
Yes.
Yes, sir.
Then why there is no acknowledgements? Very complex in nature or what?
For me personally, a bit of both. I have a bit of morning blues today, and plus, yeah, just trying to understand all the whatever you're
Okay.
saying.
So
Register
friends,
it.
keep it always simple, right? So for those who are having those morning blues, to keep it very simple, Bayes theorem is an algorithm which is based upon Bayes theorem. So the reason you see a suffix bit of name is giving the credit to another algorithm which is called Bayes theorem. So the reason I just started the journey saying that what is Bayes theorem? This is a simple formula. X stands for input, C stands for your output values present in your output variable, right? The discrete values, the categorical values that are present in your output variable are generally called as classes, which is denotes for C. So this is a simple formula. P of C given X equal to P of X given C multiplied by P of C divided by P of X. This is what you need to remember. This is what the Bayes theorem belongs to. But what is the fundamental difference between Bayes theorem and naive Bayes? Right? It is going to make an innocent assumption. What is an assumption? Which I have highlighted here. Let me also underline it. Right? it is going to make an independence among predictor variables. But what is the need? I'm going to explain now. Okay, so this is how I've taken a simple example of trying to use the formula to get the respective probability values. And a very important fact that you need to understand, Bayes theorem classifiers are used in two cases. Whenever you wanted to estimate the probability values considering all the input values simultaneously, this is where one of the case where Bayes theorem are best applied to. And the second case, few algorithms, right, will tend to ignore the variables of less importance. Okay, but this is Bayes theorem classifiers by nature, by design, right? They try to consider all the input variables. Okay, are you clear about this? So this is what we have learned so far in the last 32 minutes of time. Are you clear about this now? A quick summary of what
Yes.
we have gone through. Does it help?
Yes. Thank
Okay.
you.
So what is an assumption, right? So we just talked about a Bayes theorem formula, a simple example, and what are the best cases where Bayes theorem works good as against the other algos. Now let's try to understand what is Bayes theorem, naive Bayes theorem, right? This is what we are trying to learn and implement. So in naive Bayes algorithm, what happens? Each input value is independent. Why it is required? So in this particular case, what's happening? I'm trying to consider only one single input variable. Agree? P of C given X, where my X value was only a single value. Agree? Now, what if I'm trying to consider 100 input variables? How does the formula will look like? Just assume P of given, so instead of saying king and face, right? I'm just trying to substitute with some X and Y values. P of C1 given X1, X2, X3, all the way to X100 is equal to P of X1, X2, so on X100 given C1 multiplied by P of C1 divided by P of X1, X2, X3 all the way to X100. Do you think that those values are very easy to calculate? Since it's a single value, you are able to write them very clearly. Now, if you're trying to consider 100 input values, maybe 2000 input values, right? Calculating the probabilities are very tedious process, because when I say P of, observe this first numerical value, numerator, P of phase. What does phase mean? Here phase is nothing but your input value. X1 intersection, X2 intersection, X3 intersection, all the way to intersection of X100 given P of C1. You understand this, friends? This is not that easy to get the calculations possible, because you wanted to apply something in real time where you wanted to consider the, as soon as the inputs are given, you need to just get an answer for it, right? So if you're trying to be just dependent on your Bayes theorem, it might not be that easy to derive those computationally intensive values that quickly. You got that point, friends? So the reason your data scientists, your statisticians came up with a alteration to your original Bayes theorem, which is called as naive Bayes. What is the naive assumption? There is an independence among input variables. What does it mean? It means I'm not going to make any impact. Say that each input value is assumed to be conditionally independent given the outcome variable. It means P of X1 intersection, X2 intersection, X3 intersection given king, if they're independent of each other, how can this formula be written as? Can something through? P of X1, X2, X3 given C is equal to, if they're independent, how this particular term can be written as?
P of X1 into P of X2.
Simple, very good, right? There you go. Friends, you would understand this. If you don't remember, go to your OneNote or go to the respective video of inferential statistics where we have clearly mentioned, say that P of A intersection B. If A and B are independent, how can this be term can be written as? Remember this, friends? A and B
P
are two
of A.
events which are independent. Yeah. A and B are two events which are independent of each other. P of A intersection B can be written as P of A into P of B. Remember this? Ajay? No response? Are you clear? Able to follow? Revant, how about you? Right? So that's what we are going to do. It means the formula can be easily written, right, by using this. Okay, let me just say like how does this thing will look like. Okay, so this is how the formula can be rewritten as P of D1, D2, D3 You can say like x1, x2, x3 given C. This particular numerical term present in the numerator can be reworded as P of D1 given C multiplied by P of D2 given C multiplied by P of D3 given C, right? So this is what's happening here. Since I'm trying to consider all the evidences possible, can I say that one variable is more important than other variables? Can I say that, friends? As per the neighbors algorithm?
No.
No, we are trying to treat every evidence as of same importance, right? We are not going to say D1 is greater than D2 and D2 is greater than D3, right? Because this is what your Bayesian theorems are good at. Bayesian theorem utilizes all the available evidences. Okay, it's not going to make any disparity between the evidences that are provided to us. The moment you have input variables, they try to select all input variables are equally important. So this is how the formula can be rewritten as. No one asked this, sir, what happened to this suffix periods? You see this, friends? Have written down the Bayes theorem and also expanded in the below. So the P of C given X, if you see X1 given C multiplied by X2 given C multiplied so on Xn given by C multiplied by P of C, there should be denominator. Okay, I will say divided by P of X1 multiplied by P of X2 multiplied by so on P of Xn. Clear on this? Any questions? So this particular above formula is nothing but your neighbors. Clear?
Yes, Dhanush.
Yes.
Now clear about this, friends? Any question? Now you got an understanding why there was an assumption that is being made in order to make this calculation very simple, right? This was a naive assumption that has been made on the Bayes theorem. So the reason the Bayes theorem formula can be simply expanded into individual terms. Prior to this, I have to calculate P of x1 intersection, x2 intersection, x3 intersection given C. Now can be easily be expanded like this. Okay, so this is an advantage which will make the calculations very fast without compromising on the predicted values too. Okay, now coming to the applications again, right? Even in case of Canon, I use the same approach. It is not restricting the usage of this, but traditionally, historically, so these are the applications which are well built using on your this particular neighbors. Again, it's all right. The moment we talk about machine learning, it is all about data-driven solution. You cannot always assure you saying that this is works. It is best for such kind of problem statement, but these are like a tentative things. Whenever you want to do some real-time predictions, right? Your neighbors should be considered. And whenever you're working on multi-class classifications, can someone explain me what do you mean by multi-class?
The output variable is not two, it could be any number.
Okay, a little better answer I would expect. Friends, what do you mean by multi-class classification? You have seen this as part of introduction to ML, isn't it? Quick, what do you mean by multi-class?
Positive, negative.
I see a serious lack of revision, friends. See, that is an example of positive, neutral, or negative. If you have more than two classes in your output variable, we call them as multi-class problem statements. Friend, did we discuss this or not? This is just an example, right? Success, failure, ones and zeros, yes or no. Such a kind of examples, but you need to understand not positive, neutral, negative. That is an example, right? The moment you see more than two classes in your output variable, we call them as multi-class. Why do we need to call them as? Because the moment you talk about K&N, right? The moment you're working on a multi-class classifications, they are not the best ones to start the journey with. But when it comes to neighbors, they works really good on the multi-class classifications. It means the moment you see a particular problem statement which is having 8 classes, maybe as part of your output variable, you should immediately remember saying that hey, I should not use K&N. Maybe I should start the journey with neighbors. Only when you understand the advantages and disadvantages of each one of the algo, the moment you're working on a particular problem statement, you map or connect these dots. That's where you try to eliminate few of the circuits which you should never try. Okay, so this is what the moment you talk about multi-class, you should always think about neighbors application. Okay, and it is one of those best algorithms which can be a starting journey to work on the text classification. What do you mean by text classification, friends? If your input data belongs like a lot of categorical information, say as an example email data, maybe as an example survey information or feedback information, or maybe uh, critics ratings or reviews, right? Because they like a lot of different words as part of their reviews, which will be lasting up to some few sentences, right? So whenever you're working on such kind of a data, right, your neighbors should be the starting one that you start explore. And few examples, right? When I say text classification, email spam filtering, right? This is one of the case. And maybe customer feedback analysis, right? So these are some of those use cases that you can traditionally apply in AWS. Clear? Any questions here?
Clear.
Yes.
Very good. Now, what are the advantages? You should be able to list at least 2 to 3. No? Not even one? Gautam?
We take into account all attributes.
Okay, I got some
I
replies
think
in the
it goes
chat.
by
And
probability. It's with some mathematical methodology rather than compared to KNN.
very good. Okay, so few of the things, right? Pawan says works on text data. Excellent, right? As I said, it is one of those greatest choice that you can ever find when you are working on text classifications. The moment you're working on NLP data, right? Neighbors is one of the one that people tend to use or start their journey with. Okay, very good. The next one is Raven says uses all variables and all the data. Excellent. It means it is not going to separate or remove variables of less importance or more importance, right? It means it is considering all my weak learners. Very good points. What else? Right? It might see, because we are from a software engineering background, it might look very hard, but when you try to compare with respect to some of those other algorithm working principles, right, it is one of the simplest, isn't it? A simple formula, P of C given X equal to P of X given C multiplied by P of C divided by P of X, right? It might sound a little crazy for few people, but the moment you're trying to learn some of those complex statistical algos, it is one of the simplest to start with, right? And at the same time, it is highly scalable. What do you mean by scalable? It means it can
You
work
can
on a
increase the
small
number of
data set
variables.
and it can work on the big data too. So that is the beauty of your Navias, right? It can work on a very simple data set of 100 records, and the same time it can work on a data set with 1 million records. Okay, so that is the very beauty of your Navias. Clear on this, friends? Right? And we forgot one very important point. What is that? Pay attention. You should be able to. No? Okay, let me tell this. It can be used for your binary and also for multi-class, right? As I said, few algorithms have some kind of restrictions, right? It can give you the values, but the dependency or the trustworthiness on the results are not that great if you're trying to extend it for multi-class classification problem statements. But when it comes to neighbors, it works really good on your binary and also equally good for your multi-class problem statements. Okay, so these are several advantages that you will get as part of your neighbors theorem. Okay, now coming to the disadvantages. Can someone list down at least one? You should be able to at least list down one.
The assumption, the independent assumptions we.
Very
Yeah.
good, friends.
But what is the impact? I don't know. I mean, how it
Yeah,
impacts.
definitely. So see, because the moment you're trying to deal with the text data, say as an example, you have written a particular paragraph or maybe a couple of paragraphs, right? How many words do you have? There will be tens and hundreds of words that you're going to use, isn't it? So the reason it is okay, even though we are trying to be dependent on a faulty assumption, the impact of it on your outcome is not that really great. So the reason people are living with this faulty assumption. Can I always say this, friends? It doesn't look very weird. Equally important and independent. How can you say that each and every word present in a particular text document is equally important and it is independent of each other, right? It's a faulty assumption, but still, because of the nature of the NLP data, because of the thousands of words that are present, this particular assumption or faulty assumption is not making a great impact, right? So there is a trade-off, but as part of machine learning, there is always a trade-off, right? So the reason, because it is a disadvantage, still it is being used, and you will be surprised how the results would be, right? As part of the real-time implementation too. It is a faulty assumption, but it's still giving us and delivering us the very good results. And since I'm going to talk about the probability values, right? Whether the nature of the data should be numerical or categorical. What should be the nature of or characteristics of your input data? What should be the characteristics of your input data when I'm going to apply naive bias? Look at the formula, look at the value that I substituted, you should be able to tell that.
Numerical.
Excellent. Absolutely incorrect, Pranati.
It
Guys,
could be anything, right? Because
seriously, Ajay? Okay, you mean to say that P of C given 1 is equal to P of 1 given C, P of C divided by P of 1. Is it what you're going to say? Can you expect, in a probability, can you expect to consider a numerical value? Seriously? You can never, friends, you can never work on a numerical data. It has to be categorical only. Okay? You can never work on numerical data directly until unless you try to convert a numerical value into categorical. Friends, understand these basic fundamental things. If you wanted to apply KNN, what should be the numerical format? The input variable should be categorical or numerical in KNN. No response? What kind of a data did we work on when we're trying to solve a KNN problem statement?
Label data.
What is the
Numerical
characteristics
data.
of your input
Numerical,
variables? It's a numerical data.
Numerical data.
Friends, why is such a long pause? Trying to open the R notes or what? Friends, it's a numerical data, right? We have clearly listed down as part of your prerequisite when can you use KNN, isn't it? Friends, if you're coming to the session without revising, I will stop asking questions, right? If I stop asking questions, it would be like Rajdhani. I'll be completing one algorithm every day. This is a serious offense. If you're coming to the sessions without doing a reading of the prior sessions, this is how it will happen. Right? As I said, I'm reiterating this. Listening to Dhanush videos will not make you a data scientist until unless you revise, recollect, remember, and reconnect. Until unless you don't do these basic activities, it is near impossible for you to master data science. Okay, the input characteristics of the input variables when you're working on, when you wanted to apply KNN has to be numerical in nature. And similarly, when you wanted to work on naive Bayes classifier, the moment you wanted to apply naive Bayes, ensure that your input data type is of categorical. If it is everything is numerical, it does not make sense for you to apply naive Bayes where you convert each and every variable to categorical in nature, right? So that's what happens. So it means it is not ideal. It does not mean that it cannot apply, but there needs to be a lot of processing that you need to do to convert one data type to other data type, right? So in the same case of KNN, I told you the same. There are 31 input variables, 30 belongs to numerical and 1 belongs to categorical. How do you handle this situation? Remember, what do we do? Anyone?
Convert it into numerical.
Numerical.
How do we do it? That's the question. Definitely you need to
Data
convert it.
transformation.
Labeled.
Very good, right? What are the data transformations? Can someone quickly tell me?
Dummy code.
One hot
One.
code.
I need a little more description, right? Because I have taught you. If I have not taught you, if you were trying to search for words, I'm okay with it. But since I explained you very clearly, taking an example, providing the description, providing the challenges, and when do you use what? I need that kind of an information. Who wants to go?
For ordinal data, we use label encoder.
Excellent. Right? The moment you see your input variable to be of ordinal nature, we use label encoding. Pranati, can you explain me what does a label encoding mean?
So we try to measure the magnitude in terms of when we try to convert into numerical data.
Okay. To keep it very simple, right? Since it is an ordinal data, each one of those input value will be replaced by each one of the categorical value will be replaced by a numerical value, right? That's what we have learned. When it comes to label one-hot encoding, right? It all depends upon based upon the number of categorical values present in my output in a particular variable. I'm going to create those many number of new columns, and the presence of a particular value is being represented by 1, the absence is represented as 0. This is called as one-hot encoding. If a particular input variable has 100 discrete values, what will happen? You are going to create 100 new input columns. Always remember this. Okay. And when it comes to dummy coding, it is very similar to your one-hot encoding, except that you are going to save the new column creation by 1. Agree? Friend,
Yeah.
please do remember all these facts, right? The moment you're trying to solve a particular given problem statements, you need to explore all these kind of dimensions before you choose a particular algo. Okay. Further point, friends, are you clear about KNN? When it comes to neighbors, the input has to be categorical in nature. Okay. And what are some of the disadvantages? It is making a faulty assumption, but still, even though we have a faulty assumption, still the results are reliable for us to start using neighbors for the real-time implementations. Okay. And since we are going to talk about the neighbors as categorical data, on the moment you see more number of numerical data as particular data set, then you need to do a lot of data transformations before you start applying neighbors. So the reason, if your data set is dominated by numerical features or numerical input variables, definitely neighbors is not the right one to choose. Okay. And at the same time, the estimated probability, right? Even though we get the probability values, those are less reliable, right? Even though you're going to get the output class and its associated probability value, that the dependency, don't overly depend on the probability value, right? Those are not that greatly reliable as against the output value that you're going to get it. So these are some of those advantages and disadvantages of your neighbors. So